Hi everybody, it's Mrs. Dunn. We're talking about the normal distribution today. Specifically in this screencast, what we're going to be doing is identifying different distributions first. So we're going to identify a rectangular, J-shaped, bimodal, and skewed distribution first. So I want to go over all of those. I want you to know what those would look like, and we want to talk about examples of each. And then what we're going to do is focus specifically on the normal distribution and properties of a normal curve. And then we're going to calculate a z-score in this screencast. So there's two parts to this screencast. This is the introduction. Make sure that you watch the second screencast, which will get into more of the calculations that you're going to have to perform in your homework. Okay, so first of all, we're talking about a rectangular distribution. In a rectangular distribution, the frequency is on the vertical axis and the values would be on the horizontal axis. And in a rectangular distribution, the frequency of each of these data values should be the same. So an example of that would be if we rolled a fair die like 100 times. We would expect the number of times a 1, a 2, a 3, a 4, a 5, or a 6 would be rolled would be the same for all of those values. So the frequency should be the same if we roll a 1, a 2, a 3, a 4, a 5, or a 6. So that would be a rectangular distribution. You could think of it as a probability. And when you, or if you take statistics, you will learn about this in terms of probability. So we would say the probability of rolling a 1, a 2, a 3, a 4, a 5, or a 6 is the same if the die is fair. Another type of distribution would be a J-shaped. That's a J-shaped because you're steadily increasing or steadily decreasing. An example of that might be the number of hours a student studies the week before a final exam. So you're going to study less on the first day, but the night before the exam, you're going to be studying the most. So here's where we see a J-shaped. That would be like part A, of these two examples. The number of hours a student studies the week before an exam would be most like example A. Next, we have a bimodal distribution. With a bimodal distribution, you have two values that are clearly higher than the others. Not necessarily the same, but excuse me, but both of these are higher than the others. An example of this might be like for example, if you took the weights of 100 people in a room, you would expect there to be two different modes. Like the frequency of women might have, most women might have a weight here, whatever that would be, 140 pounds or whatever. And then over here, it would be higher for men. So there's an example. You could talk about heights or weights, and you would expect that to be different for men and women. Next, we have a skewed distribution. This distribution is considered to be skewed to the right, and this is skewed to the left. If the tail is more on the right, so you'll notice that it's increasing and then it starts to decrease, and it's getting smaller and smaller, and that tail is getting smaller to the right. So we say distribution A is skewed to the right. Distribution B is skewed to the left. And then an example of this that would be most like example A would be if you were going to poll like all your classmates and how many computers are in their classroom, in their household, I mean. You would expect that most houses are going to have 1 or 2 or maybe 3 computers. The chance that they would have like 10 computers in their house is very small. So the frequency would be really small. So that's an example of a skewed distribution. We're going to spend most of our discussion talking about a normal distribution. So here's an example of a normal distribution. And some of the characteristics is, first of all, this graph is considered to be a normal curve. And this normal curve is bell-shaped. And you can see how if we were going to connect all these, make kind of like a polygon here, you could see that this would be bell-shaped. And the curve is bell-shaped and symmetric about the mean. And the mean, the mode, and the median are the same, which would be whatever this value is for this bar right in the middle there. That would be the mean, the mode, the median of this normal distribution. Some other characteristics, and this has to do with the empirical rule, is that 99.7% of all the data is going to be within 3 standard deviations of the mean. 95% is within 2 standard deviations, and 68% is within 1 standard deviation of the mean. I don't know if you remember this from your homework, but you had a question where you were looking at the graph. I believe it had to do with the weights of boys and girls in their preteen years. So if you remember, you were looking at that, and it was showing you the spread of the data. So we're saying the spread of the data, 99.7% of the data, is going to lie within 3 standard deviations of the mean. So that means 3 standard deviations below and 3 standard deviations above. Each of these lines represents a standard deviation. So in the middle, we have the mean. This is 1 standard deviation away, 2 standard deviations, 3 standard deviations above the mean. This would be 1 below, 2 below, and 3 below. And this is actually called the empirical rule, which is highlighted here. And I went through all this with you. But you want to make sure you remember this. You're going to see this again if you happen to take stats. Okay, so now let's turn our attention to these z-scores. So what exactly is a z-score? Well, a z-score represents how far in terms of standard deviations we are from the mean. You remember the normal distribution is all about the mean, and the spread of the data is in terms of standard deviations. So where exactly in that diagram is a specific data value? So a z-score represents how far in terms of standard deviations a specific data value is from the mean. So that means if you have a z-score of 2, that means that that piece of data is 2 standard deviations above the mean. If the z-score is 0, that means you're at the mean. And if the z-score is -1, that means you are 1 standard deviation below the mean. Here's a formula for calculating the z-score. So to find a z-score, you're going to take the piece of data, whatever it is, subtract the mean from it, get that answer, and then divide by the standard deviation. Here's an example. So imagine that we have a normal distribution with a mean of 75 and a standard deviation of 5. Determine the z-score for the following values. So we're going to do 3 examples, 60, 75, and 81. Now, first of all, you want to notice that we have a mean of 75 and a standard deviation of 5. So I wrote that down for you. So when we want to find the z-score for that specific data value 60, we're going to take the data value, subtract the mean, that's from this formula, and divide by 5. So 60 minus 75 is -15, and -15 divided by 5 is -3. So the z-score is -3. Let's do the next one. For 75, it's going to be 75 minus 75 divided by 5. Well, 75 minus 75 is 0. So the z-score for 75 is 0. Doesn't that make sense? What's the mean? The mean is 75. So how far from the mean are we if we're at the mean? Well, we're nowhere from the mean. We are 0 standard deviations away. And then lastly, we have this example of 81. 81 minus 75 divided by 5, which is 6, and 6 divided by 5 is 1.2. So the z-score for 81 is 1.2. Okay, that's all there is to it. Please watch the next screencast so that you know what we are actually going to do with these z-scores now that we figured them out. All right, good luck.